Okay, today we will be putting all our formulas together and finding the volume and surface area of composite shapes. Composite solids means that they're created of more than one solid put together. So if we look at this first one, it is made up of a cone, and the bottom then is a cylinder. And it wants us to find the volume of it to the nearest cubic centimeter. So that means the nearest whole number. And it says to use 3.14 for pi. So we split it into the two solids we know the formulas for, and then at the end, since this one's the total, we're going to add it together. So the volume of the cylinder formula is pi radius squared times height. So pi is, just like it said, 3.14, and I'm looking at the cylinder. So the cylinder, if I go ahead and highlight the cylinder part, this is going to be my cylinder part. So in order to do that, my radius then of my cylinder down here is 8. So 8 squared times the height, and I only want the height of my cylinder. So only the cylinder height is 7. Oops, sorry about that. So then I calculate that out and I get 1,406.72. And you don't want to round until the very, very end. So now I find the volume of the cone. So the volume of my cone then is that top part. So again, if I highlight the part we're talking about, here's your cone. And you have to know the formula. So the formula is 1/3 pi radius squared times the height. So we'd have 1/3 times 3.14 times the radius, and the radius is still going to be the exact same that of the cylinder, so it's still 8. So 8 squared times my height. Well, that's a little bit trickier. We want the height of just the cone. The total is 13. From here to here was 7. So that means here to here is 7. Oops, if I can get it to work for me here. Here to here is 7. The total is 13. That means this part up here is 6. So when I go ahead and I calculate that out, that's 401.92. Now I need to go ahead, since it wants it the composite, I add that together. So when I add that together, that gives me 1,808.64. Well, we have to remember it said to round to the nearest cubic centimeter. So that's going to be approximately 1,809. And we have to put the correct label on it. It's volume, so it's cubic centimeters. And don't forget about that 1 there. That's kind of hard to see. Our next one then is made up of a hemisphere this time, which is the bottom part, and then a cone again. And it says the cone is attached to the hemisphere with the diameter of 10 centimeters. The slant height of the cone is 13. What is the surface area of the toy? So this time we're flipping the surface area instead of volume. This time it says use 3.14 again, but this time we're rounding to the nearest 10, so you have to be careful on the directions. So we are going to have to find the surface area of each part, and then once again we'll add it together. So the surface area of a hemisphere, well, we know a sphere is 4 pi r squared. Well, a hemisphere is half of that, so I'm going to have to find half of that. So if I go ahead and I replace that, that's half times my formula, which is 4 times pi, which we are using 3.14, times the radius. Well, if this is my hemisphere, the diameter it says is 10. Radius would be half, which is 5 then, so 5 squared. That gives me 157. So now we're going to be looking at the cone part. So here's your cone again. And the area of the lateral surface of the cone, because if we're talking about surface area, we don't want the part that is where those two shapes are meeting, because that's not the outside surface area. So we only want the curved surface of this cone part. So the only part of our formula that we're going to use is pi times r times L. Pi again is 3.14. R always stands for radius, so if I look here, my radius would be 5, just like the hemisphere. And L stands for slant height, so my slant height here on the cone is 13. That gives me the lateral surface area of the cone is 204.1. To get the total surface area of the toy, I'm going to add these two together. And it's said to the nearest tenth, so we get 361.1. That's already to the tenth, so we don't have to do any rounding. And since it's surface area, it's square centimeters. So we get 361 and 1/10 square centimeters. Okay, our next one is a little bit different from them because before we added, well, on this one it's talking about this is a candle holder. And you're going to set the candle on the inside right here in the yellow part. So that means that part had to be cut out of the original cube. So what we're going to have to do is we're going to have to find the volume of the cube, the purplish blue part, the volume of the cylindrical hole, which is the yellow, and this time we're going to have to subtract because that's taken out so a candle can set in there. So our volume of a cube is very simply, you can think of it as length times width times height, or since it's a cube and they're all exactly the same, you can just think of it as length cubed. So we have 15 cubed, which equals 3,375. The volume of a cylinder then is pi radius squared times height. So I use 3.14 times my radius of 2.5 squared times my height. Then we only want the height of the cylinder, which is given to us over here on the side as 9. So that gives me 176.625. Then, to get the volume of the candle holder, like I said, that yellow part's taken away, so we have to subtract. So I'm going to subtract those, and it's set up above to round to the nearest cubic centimeter. So that's to the nearest whole number. So when I subtract, I get 3,198.375. Well, the nearest whole number, that 8's followed by a 3, so it stays the same. So that's going to give us an approximate volume of the candle holder as 3,198. Volume is cubic centimeters. Be very careful on those labels. Okay, you are done listening to me for today. So your guided practice is page 164, number 1, page 165, number 2, and page 166, number 3.